Hello and welcome, and in this video we're going to look at inequalities. So a lot of number lines and working out what x is. Right, before we even look at inequalities, we need to go over, or if this is your first time even looking at inequalities, we need to learn what these types of numbers are, the different types of numbers. So let's start with natural numbers. And the symbol given for natural numbers is simply the letter n. Okay, n for natural. Now, what are natural numbers? Well, natural numbers are positive whole numbers. Okay, so there's no like fractions, no. And there's no negative numbers. So you wouldn't have a -3 as a natural number. They're simply positive whole numbers. So they begin at 1 and they're the counting numbers. So 1, 2, 3, 4, 5, 6, all the way to infinity. They don't end, but they do have a starting point, and that is at 1. Okay, the first natural number is 1. 0 is not a natural number. Okay, so the first type of number are the natural numbers, n. Another type of number are integers. Now, integers are positive and negative whole numbers. So, whereas natural numbers begin here and go up, 1, 2, 3, 4, integers actually contain 0 and all of the negative whole numbers as well. Okay? So that's what an integer is. An integer is a positive or negative whole number. So there are no fractions, no decimals, just whole numbers. Okay, whole numbers, positive and negative. And finally then, for this little lesson, we're going to look at real numbers. Real numbers are all numbers. Okay, so positives, negatives, fractions, surds, everything. All numbers, real numbers. Okay, so they include everything. So we've 3 different types of numbers there. We've got natural numbers, we've got integers, and we use the letter Z, by the way, to indicate if a number is an integer or not. And we have real numbers, and we use the letter R for real numbers. You'll notice that there's, let me just delete that and put it in a different color, because you'll notice that for the first 2 types of numbers, so natural and integers, there's a kind of a similarity. And the similarity is that they both are talking about whole numbers. Okay? Now, for natural, we're just talking about the positive whole numbers. For integers, it's positive and negative. And then for real numbers, it's not just about whole numbers. You do include the whole, but everything else, so fractions, all the rest. Okay, so there's a similarity really between natural and integers. Okay, it's important because we'll come back to that in a moment. Now, also what you need to look at and need to learn how to use and think about is the number line. Okay, the number line, because in maths it comes up an awful lot. So in my little number line that I've drawn here, I started off at 0, because 0, as we consider, some people think is the bottom number. Of course it isn't. And then it starts getting bigger. The numbers start getting bigger as you move to the right, bigger. So from 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8. Now I can't be here all day, so I just put an arrow in to show that the numbers will continue on to infinity. But of course that's not a number line, because numbers don't stop at 0. Okay, there are more numbers. Even if you think of a thermometer at home when you're sick and you measure some temperature, or when it's very cold, you can go into the minus temperatures. Okay, so a number line contains minus numbers too. So we have to go this way for minus numbers. So -1, -2, -3, -4. So they start, the more to the left you go, the smaller the numbers get. Minus 4 is actually smaller than minus 1. Okay, think of it in temperature terms. Minus 4 is colder than minus 1. Okay, these are smaller temperatures, smaller numbers. Okay, and they also, so that's a number line. A number line contains the negative numbers and the positive numbers. Okay, with 0 sort of in the middle, balancing the two. Now, if I were to tell you that I have a number in my head, I'm not going to tell you what the number is, but I have a number in my head. Okay, I'm going to give you a clue as to what it might be. I'm going to tell you that it's a natural number. Okay, and I'm going to tell you that it's less than 6. It's a natural number and it's less than 6. Now in maths you write that. You don't tend to write a sentence to explain what you're talking about. You do it in maths symbols. So to say that it's a natural number, we say that the number I have in my head, I'm going to call it x. Okay, if I told you what it was, I'd be giving you the answer. So I'm going to call it x. And I'm going to tell you that x is an element of natural numbers. That means that it is a natural number. And if I tell you that it's less than 6, then I write this. X is less than 6. Now how do I know that that's the less than sign? Because the small part of the sign is pointing to the x. So that means that x is smaller than 6. See, the big part is pointing at 6. So it means x is smaller than 6. So that's why I say x is less than 6. Right, so that's it written again. Now can we represent this on a number line? How do we show what I've just said, or what this beautiful person over here has just said, on a number line? Well, I draw my number line, and a nice idea is to put the number that they give you in the middle, 6, and build up from 6 and build down from 6. And it's always nice to try and get into the minus numbers. So if I build up from 6, we're talking about 7, 8, 9, 10, 11. I'm building down 4, 5, 4, 3, 2, 1, 0. Okay, I'll stop there. No need to make your number line massive. Right. So is x equal to 6? Let's see. Well, it's less than 6, isn't it? So it could be 5, couldn't it? It could be 4. It could be 3. It could be 2. It could even be 1. Could it be 0? No. Because I'm also told in the question that it's the number I have in my head is a natural number. And remember what we learned earlier on about natural numbers? Natural numbers begin at 1, okay, and go up. So the number I have in my head is either 1, 2, 3, 4, or 5. That's it. I'm not telling you what it is. I've just given you a range of possible answers. And that's the question done. Okay, usually you'll never get it whittled down to one answer. It's just showing you the different options that the number in my head could be. And telling me that x was an element of natural numbers helped me to do that. So these two pieces of crucial evidence here, these hints, helped me to draw that number line. Okay, let's do another one. I have a number in my head. And what a lovely head it is. Now the number, it's greater than minus 5. So in maths terms I'd write that like this. Notice how, let's zoom in on this. It says that x, and the big part of the symbol is pointing at x. That means that x is bigger than whatever's over here. So x is bigger or greater than minus 5. Lovely. And it's an integer. Okay, it's an integer, so it's an element of z this time. Right, so let's draw the number line. Quick draw of a number line. We should always use a ruler now for doing this. Put the number that's given in the question in the middle. We put -5 here. Now, this is where people can make mistakes. Be careful how you number this number line. What would be here? It's -4, -3, -2, -1, 0, 1. And what would be here? -6, -7, -8. No harm to practice drawing number lines. Now, let's see what we need to do here. So, it's greater than -5. It's greater than -5. And it's an integer. So what could it be? Well, it could be -4. It could be -3. It could be -2. It could be -1. It could be 0. It could be 1. It could be going on forever. So I put a little arrow in to show that it could be any number even further on. It's just that I don't have the time to draw it. It would take me forever. Okay, so it was bigger than -5, so we were going. Actually, in fact, the arrow helps tell you what way to put your dots. So we started at -5. Now it's not equal to -5. It says it's bigger than -5. So -4 is bigger, and we're going in that direction. See the way the arrow is pointing in that direction. That's why we put dots there, 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 and there, and there. Okay. Now let's try one of these ones. This angry man here, he has a number in his head as well. Now it's less than 4, and it's a real number this time. Okay, it's less than 4. Right, let's go and draw the number line. This is how it would be written, typically, like that. Now that's a bit crooked. We'll do that again. Okay. Put the number given, this number, in the middle, and build up from it. Maybe 5 different numbers. And down from it. 3, 2, 1, 0. I'm going to the minuses, why not? -1. Right. Let's see what evidence we have. What have we been told? We're told that x is smaller than 4 because the smaller point is pointing towards the x. So x is less than 4. Okay, so what could it be? It could be 3. It could be 2. It could be 1. It could be 0. It could be -1. Because remember, real numbers are all numbers, positive and negative. And we're told that this is a real number. Right, but couldn't it also therefore be 2.5? Because real numbers contain fractions, decimals, everything. So if I'm being told that x is less than 4 and that it's a real number, well, technically speaking, x could be 3.5. It could be 3.6. It could be 3.2. It could be 3.8 or 2.8. It could be 2.2. It could be -0.5. It could be 0.5. It could be 0.9. It could be the square root of 3.9. It could be any of those numbers. So when we're told that x is an element of R, we don't use dots like we've been using for n and z. See the way we were using dots for that z, for that integer, and for x is an element of n, we use dots. When we're told that x is an element of R, we actually shade. We colour in the entire number line. So it's less than 4, so it could be any of these numbers and into infinity down in the negative numbers. And remember, look again how the arrow is pointing that way, and that's why we're going that way. Now, the only thing is it equal to 4? Does it say that it's equal to 4? Because if that symbol if it said this, x is less than or equal to 4, well then I would continue my shading right up to the 4. But it doesn't say that. It says that it's less than 4. So in this case, I have to put a little empty little bubble around 4 to show that I'm not highlighting 4. I'm going to shade everything less than 4, but I'm not highlighting 4. And that tells somebody looking at the number line that, oh, it's not 4, it's simply everything less than it. Okay, I hope this little video helped revise a little bit about natural numbers, integers, and real numbers, and how to represent them on the number line.